Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Octane number or octane index is a parameter characterizing the ability of gasoline not to ignite from compression. The index is equal to the volume percentage of isooctane in a mixture with N-heptane, at which the detonation stability of this liquid and the gasoline under study coincide. The first to investigate the ability of gasoline to detonation in the 21st year of the last century was an Englishman, Harry Ricardo. He proposed to use a scale of gasoline resistance to detonation. For a long time, the main anti-detonation additive for gasoline was tetryl lead. Adding only 0.01% of this substance to gasoline increases its detonation resistance index by 3 units. But since it is very poisonous, now its use as a gasoline additive is prohibited. Instead of it, in order to increase anti-detonation properties, safer additives are now used. For example, methyl tert-butyl ether, which is considered to be the most promising means for this purpose today. Its mixture with tert-butyl alcohol is also used. The disadvantages of these additives are their high aggressiveness to rubber products and their low, about 50 C, boiling point. The latter is the reason for vaporization of these additives from the fuel in the heat. Regardless of the chemical nature of the antidetonator, the concentration of the additive in gasoline is limited for objective reasons, leading to a low increase in octane number. In addition, the increase in the detonation stability index of gasoline depends on the concentration of the additive nonlinearly. For each anti-knock additive there is a threshold concentration, after reaching which the detonation stability index does not increase. Comparison of the properties of various anti-knock detonators. The threshold concentration values of some additives and their other operational features, oxygenates, lower alcohols and simple esters. Threshold concentration of the additive is 15%. Features, relatively low heat of combustion and high aggressiveness towards rubber products. Maximum increase in octane index of fuel 4 to 6 units. Parameters of several esters used as additives. Methyl tert-butyl ether, MTBE, average octane number 114, boiling point 55 C. Ethyl tert-butyl ether, ETBE, average octane number 110, boiling point 70 C. Methyl tertamyl ether, MTAE, average octane index 104. 5, boiling point 87 C. Disopropyl, DIPE, average octane index 104.5, boiling point 69 C. Containing manganese. The threshold concentration of the metal in fuel is 50 mg per liter. Features, increased wear of cylinder piston group parts, significant carbon deposits on spark plugs and in the combustion chamber. Maximum increase in detonation stability index is 5 to 6 units. Iron containing. The threshold concentration is 38 mg per liter. Leads to increased wear of engine pistons and cylinders due to noticeable ash deposition during combustion. Maximum increase in detonation resistance number of gasoline 3 to 4 units. Aromatic amines, such as aminobenzene, aniline, which is prohibited for use in pure form due to extreme poisonousness. Of the substances in this group, only monomethylaniline, N-methylaniline, is approved for use. The threshold concentration is 1 to 1.3%. The peculiarity of the additive based on this substance is high octane number. In the process of experimentation, a value of 280 units was obtained. However, there are also significant disadvantages, to which can be attributed a significant deposit of resin on the engine parts and fuel system. There is also increased wear of cylinder piston group parts. The maximum increase in the number of detonation resistance of gasoline, achieved by the use of such an additive, is 6 units. Reducing the risk of detonation by improvised means. How to reduce the risk of detonation by improvised means, adding 10% of ethyl or Any other alcohol to gasoline can increase its octane number by 3 units. The disadvantage of this method is the formation of vapor plugs in gasoline lines, which complicate the operation of the fuel system. This is due to the rather low boiling point of alcohols, which is especially noticeable in hot weather. Another disadvantage of this technique is that alcohols are very hygroscopic and well absorb moisture from the air, which in a severe frost will freeze, forming ice plugs in the fuel line. Of course, access to gasoline in such a case will be blocked. It is possible to increase detonation resistance of gasoline fuel by adding acetone to it. According to the data published in the Network Amateur Experimenters, adding 1 liter of acetone to 20 liters of gasoline increases its octane number by 6 units. They, however, did not measure, being guided only by detonation. A car, the engine of which is designed for AI-98, was filled with AI-92 and acetone was added to the fuel until detonation disappeared. In conclusion, increasing the octane number of gasoline at home can be achieved through various methods, primarily by using specific additives that enhance fuel performance. Understanding the composition of these additives is crucial, as they can vary widely in effectiveness and safety. While options such as ethanol, iso-octane, and certain commercial octane boosters are available, it's important to approach this process with caution and awareness of your vehicle's requirements. By carefully selecting and applying these methods, you can potentially improve your fuel's efficiency and performance. Always remember to prioritize safety and consult with professionals if you're unsure about any aspect of modifying fuel. Thank you for watching, and we hope you found this information helpful.